Hi everyone, this is a lesson on solving equations with quadratics. So the context is, if you're in my class, we've talked about all these different ways to solve quadratics, and now we're going to actually go back and review some things that we've seen in the past. But just take a look at kind of what happens with some of the quadratic equations that arrive out of kind of solving these types of equations. So as a reminder, pause and try the examples when you are prompted, and there are always free guided notes available. So let's take a look at this first problem here. 2 over x minus 1 over x plus 1 equals 2 over 3. So you may or may not remember, so because we have all fractions here, what we're going to want to do is we're going to want to find the LCD of them so that we can actually cancel out all the fractions. So in this case, my LCD is going to be 3x times x plus 1. So what I want to do is I want to multiply every single part of this equation by this LCD so that I can ultimately cancel out the denominators. So let me set that up. So now what I can do is I can go through piece by piece, since I've set this up, literally the LCD by each part of this. So I can just go through now and make some cancellations. So for instance, with this first part here, so this is x and x, these will cancel out, so this will cancel out and this will cancel out. Coming over to this next cluster, so the x plus 1 and the x plus 1, those will drop out, so I'll cancel those out. And then finally, the 3's here, those will drop out. So I will go ahead now, and I want to just restate all of this, and I don't want to do too much. So I'm just going to restate this. So this is 6 times x plus 1 minus 3x equals 2x times x plus 1. Okay, so here's where I'm at now, and now I'll go ahead and distribute and see where I'm at. So when I do this, I get 6x plus 6 minus 3x equals 2x squared plus 2x. And so now I can go ahead and start collecting my like terms. So I get 3x plus 6 equals 2x squared plus 2x. And now we can just kind of plow ahead with this. So I can see that I've got this is squared. So I'm going to want to bring these two terms over, and then I'll try to figure out what else I can do. And so this is kind of the theme, I guess, of this lesson, is that you're going to have everything's going to end up with a quadratic. That's kind of what I mean by solving equations with quadratics. It's things that you've seen before, but now just kind of looking at it again with everything that we know about quadratics. Okay, so I need to write this out now, so let me clear some space. And so this will become, let's see, 2x squared minus x minus 6 equals 0. Now, this is kind of the part of the lesson where anything goes now with these quadratics. So ideally, they will factor, and in this case, this does factor, but it's not always going to work out like that. You'll have to think of all the ways that you know to solve quadratics, really. So if you want to pause the video and maybe try to finish this, go for it. Hit play when you're ready. So if I factor this, so this factors just a little bit differently. So this will give me 2x squared, and then this will give me negative 4x plus 3x. That'll give me the negative x, and then I've got the negative 6. So there's kind of all the pieces of this, and then just remember, you can set each piece equal to 0. So let's see, I can subtract off the 3, so I get 2x equals negative 3. So one solution will be x equals negative 3 over 2. And then the other one, if I just set x minus 2 equal to 0, so I can just add the 2 to each side, and I get x equals 2. So my two solutions in this case are negative 3 over 2 and x equals 2. Now, just remember the other part of working with these types of equations. The thing that you want to make sure of is that you did not end up with a 0 in the denominator. So if I was looking at this particular fraction here, so if I got, say, x equals negative 1, that would be a problem because then I have a 0 in the denominator. Or for this one, if I got x equals 0, that would be a problem. But in this case, we don't have that, so we can just keep going. Another way that we've seen in the past where quadratics came up were situations like this. So do you remember how to solve this? You solve it by squaring both sides, but when you square both sides, you end up having to FOIL this side because there's two terms here. So if I go ahead and I work that out, I get 2x plus 8, and then I need to really multiply. Let's see, I'll just write this maybe in the notes here. This needs to be x plus 4 times x plus 4. So then I get x squared plus 8x plus 16. And this is kind of the same thing, right? So you can see here that you're going to have to end up factoring this. So I'm going to go ahead and I'm going to subtract off the 2x, and I'm going to subtract off the 8. So now I get x squared plus 6x plus 8 equals 0. Now, in this situation, this does factor, right? And that's kind of the ideal. So this will factor as x plus 4 times x plus 2. So I get x equals -4 or x equals -2. And those would be my two solutions. Now, remember that you do actually have to go back and check them. So in this case, then I will plug this in. So let's just do a quick check on the side. I'll just write it right over here and write out all the work. And so I can see with both of these both work out, so we're good to go in this case. So with these types of problems, this is just going to be kind of the way that it goes. So just to be nice and complete, I have 2 examples here for you to try if you just need to refresh those skills. So pause now and hit play when you're ready. Okay, so for this first one, so this is another one where we've got to find the LCD. So in this case, my LCD is just x minus 2 and x minus 3. It would be redundant to have x minus 3 more than once because x minus 3 never appears in the denominator more than once. So what I need to do now is multiply all of these by the LCD. So I'll go ahead and do that. Okay, and so now that I've got everything kind of laid out here, sorry it's a little squished, now I can go ahead and make some cancellations. So here in this little cluster, so the x plus 2's are going to cancel out. In the next cluster here, the x minus 3's are going to cancel out. And then in the last cluster here, the x minus 3's will cancel out again. So now let's see what I'm left with. I'm left with 4 times x minus 3 plus x times x minus 2 equals 2 times x minus 2. And so now I can go ahead and distribute. So I get 4x minus 12 plus x squared minus 2x equals 2x minus 4. So now you can see that I've got that quadratic again. So let me get everything to one side. And so now here's what my quadratic turns into. So this will not factor nicely. So then what we can do is we can use really any of the other methods. And in this method, this would actually be best for the square root property. So if you just add 8 over to the other side, so now you get x squared equals 8, and then you can actually just take the square root of each side. So there's more than one way you could have done this, but this would have been the most efficient way, so that you'd ultimately get x equals plus or minus 2 times the square root of 2. So that's one way, but that's the final answer that you should have gotten for that one. Now for this last one, so we know for this one we're going to have to square both sides as shown. So I need to FOIL out the other side, so let me just show what that's going to look like. So now that I can see that x squared, I'm going to have to bring these terms over to the other side, so let me do that. And so now you can see, once again, this is definitely not going to factor. It would not be great to use something like completing the square for this. So this is another one where you're going to have to use the quadratic formula. So in this case, I've got my a is going to equal 1, my b is going to equal -9, and my c is going to equal +4. So let me show you what that looks like when you plug all of that in. And so this is actually as far as you can really go with this one. There's no perfect square that goes into 65. So besides breaking this up into 2 pieces or maybe writing it as a decimal, this would be the structure of the last one. So that would be it. And so that really covers it for this particular video. So I have more videos on how to work with quadratics or just other applications of quadratics. So please feel free to explore, and thanks for watching.